Think about what really holds our modern civilization together. Is it the oil flowing through pipelines?
Hmm.
Or maybe the massive fiber optic cables that are running under the oceans?
You might think so, but it's actually something much, much smaller, far more precise.
And utterly indispensable.
Exactly. Every single facet of the global digital economy, from the phone in your pocket to the most advanced AI cluster, it all rests on a single, incredibly fragile supply chain choke point.
And that's what we're here to talk about. We are diving into a crisis that plays out in nanometers, not miles. The AI systems reshaping our economy, the medical devices we rely on, even the most sophisticated weapon systems.
All of them depend on chips from one company in one place.
The Taiwan Semiconductor Manufacturing Company, or TSMC,
Mhm.
located on the island of Taiwan.
And the central tension of our deep dive today is this extreme concentration. I mean, it's a staggering figure. TSMC produces over 90% of the world's most advanced logic chips.
90%. We're talking about the sub-7 nanometer chips, the ones you need for any cutting-edge technology.
So our mission is to understand how this one company achieved total global dominance.
And the near-impossible engineering that maintains it.
Hmm.
Which then leads to the big question. Is this dominance a silicon shield that protects Taiwan?
Or is it just a massive target painted on its back?
Let's start with the scale of this reliance, because the financial gravity of TSMC is, well, it's hard to wrap your head around.
It really is. Their market hegemony is startling. So they control about 65% of the overall global foundry market.
Which is already huge.
It is, but the real power is at the cutting edge. When you look at 3-nanometer production capacity, the tech that defines leadership today, they hold 95% of it.
95.
It's a near monopoly.
And yeah, that kind of concentration, it translates into a staggering valuation. By late 2025, TSMC's market cap hit, what, $1.55 trillion?
Making it the largest company in Asia. And look at their profitability, a net profit margin of over 40%.
For a manufacturing business, that is just extraordinary.
It is. They can command that premium because no one else can match their reliability.
So who's relying on them?
Well, the customer roster reads like a list of global tech royalty. They serve 522 customers, but the major players are breathtakingly dependent.
Apple, for instance.
Apple accounts for about a quarter of their revenue, and they've already locked up over half of TSMC's capacity for the next generation, the 2-nanometer node.
Then you have NVIDIA, the entire AI explosion we're living through.
It's being manufactured by TSMC. NVIDIA's AI accelerators are consuming over 50% of TSMC's advanced packaging capacity. That's a technology called CoWoS.
The high-performance computing, driven by AI, is now over half their business. They are literally manufacturing the intelligence revolution.
But the dependence isn't just commercial, it's strategic. And this is where the national security exposure becomes unavoidable.
Right.
Critical U.S. defense systems, we're talking about the F-35 fighter jet, Patriot missile batteries, the HIMARS rocket launchers.
The Aegis combat system.
All of it relies on specialized chips, FPGAs, that are manufactured by TSMC.
So let me just get this straight. Some of the most sensitive, most advanced parts of U.S. military infrastructure rely on a facility that's less than 200 kilometers from mainland China.
That is the crucial context. And to add another layer of tension, only 2% of the devices used in U.S. military systems are currently produced by domestic so-called trusted foundries.
Only 2%.
Meaning facilities whose security is actually guaranteed by the U.S. government. The vast majority of the specialized chips that power American defense originate in Taiwan.
That sets the stakes dramatically.
That's it.
So the next logical question is, why? Why can't Intel or Samsung or some state-backed Chinese company just throw billions at this and catch up?
And this is where you get into the engineering moat. It's built on decades of singular focus. The foundation was laid by one man, Morris Chang.
Right. He founded TSMC in 1987 at age 56.
With a lot of help from the Taiwanese government, which provided nearly half the capital. But his revolutionary insight wasn't a new piece of hardware. It was a whole new piece of hardware. It was a whole new business model. The pure play foundry.
Before Chang, companies were integrated device manufacturers. They designed and they built their own chips.
Exactly. Chang realized that as manufacturing got exponentially more expensive and complex, there would be a massive market for fabless companies, designers like NVIDIA or Apple, who just needed a manufacturer that would never, ever compete with them.
And that model unleashed this explosion of innovation.
It enabled the entire global mobile and computing revolution. But to stay on top, you need this continuous, brutal technological escalation. You have to keep pushing the boundaries of physics.
And when we talk about a node like 3 nanometer, we should probably clarify for everyone listening, these names are mostly marketing labels now, right?
They don't refer to an actual physical gate length anymore, but the scale is what matters.
Mm,
A feature on a 3 nanometer chip is, it's pushing the limits of reality. It's only about 15 silicon atoms wide.
15 atoms.
And to print patterns that small, you need a special kind of light extreme ultraviolet, or EUV lithography. The light has an incredibly short 13.5 nanometer wavelength.
Okay, we have to stop on the physics of this for a second. How do you even generate that kind of light?
This is the part that sounds like science fiction. You take a powerful CO2 laser and you fire it at tiny, tiny droplets of molten tin,
Molten tin.
50,000 times per second.
Wait, 50,000 times a second?
And when the laser hits the tin, it vaporizes, creating a plasma that reaches temperatures over 500,000 degrees Celsius.
That is literally hotter than the sun's surface.
It is, contained in a vacuum, just to print a pattern on a silicon wafer. And the equipment to do this is its own choke point. It only comes from one company.
The Dutch company ASML.
Right. Each machine costs between $200 and $400 million. It needs 250 specialized engineers 6 months just to assemble it. The barriers to entry are practically insurmountable.
But the true secret sauce, the reason TSMC is so far ahead, it's not just owning the machines, it's the operational precision. It's the yield rate.
That's it. Yield rate is everything. It's the percentage of functional chips you get out of a single batch.
And TSMC's is.
90% or better at 3 nanometer. This operational excellence, this is their critical moat.
And the competition.
Samsung has struggled severely. They've reported yields closer to 50%, and sometimes even as low as 20% for certain high-end products.
So a 40+ percentage point gap.
That gap in functional chips means TSMC is uniquely reliable, which is why Apple and NVIDIA only trust them with their crown jewels.
And that operational perfection is maintained by a work culture you've described as almost militaristic.
It's intense. The fabs run 247, 365 days a year. They have these night owl R&D teams constantly refining processes. If a machine goes down, the engineer responsible is expected on-site immediately.
It's a cultural advantage that Western companies find very difficult to replicate.
Incredibly difficult.
So the secret isn't just money or machines, but this intense, centralized culture that can only really exist there? That brings us directly to the core geopolitical debate.
The silicon shield.
The theory that Taiwan is simply too important to fail.
Exactly. The idea rests on economic deterrence. Because Taiwan is so indispensable to the global economy, and especially to China's own tech sector, an invasion would be economic suicide for Beijing.
Right. There was that Bloomberg economics model, which projected the cost of a conflict would be a 10% hit to global GDP.
About $10 trillion in losses. That's a deeper shock than the 2008 financial crisis or the pandemic.
And Morris Chang himself has said that TSMC's role may make someone refrain from attacking.
China relies on Taiwan for a massive percentage of its high-end chips. Wiping out TSMC would cripple their tech ambitions overnight.
But the critics always push back on that, right? They argue China's desire to control Taiwan is ideological, it's historical, it predates semiconductors.
And they ask a very uncomfortable question. Will economic pragmatism really deter an ideologically driven goal?
Which leads to the darkest counter theory.
The broken nest scenario. Deterrence by punishment. Analysts have proposed that Taiwan should explicitly threaten to destroy its own fabs in an invasion.
Deny the prize to Beijing.
And what's fascinating is there's a technological reality to this. The kill switch revelation.
Oh, right.
Investigations confirmed that ASML and TSMC have developed remote capabilities to disable or even brick those multi-hundred-million-dollar EUV machines if an invasion happens.
So China couldn't just walk in and take over the fabs.
Not easily. They'd inherit useless, incredibly complex paperweights.
But the Taiwanese government has rejected the broken nest idea, haven't they?
They have. Publicly, military officials have called it counterproductive. They are still relying on the economic deterrent, the silicon shield, not the threat of destroying their own most valuable asset.
Okay, so the risks aren't just geopolitical. They come from the very ground the island sits on.
This is the concentration problem in its rawest form. All 12 of TSMC's major fabs are on Taiwan's west coast, just 130 kilometers or so from the mainland.
But the island also sits on 42 active fault lines.
And we saw that vulnerability during the big earthquake in April 2024.
Though the resilience was impressive.
Very impressive. They recovered 70% of their tools in 10 hours. They built for tremors, but what they're struggling with are more basic resources.
You mean water?
Water and power. A single advanced fab uses 5 to 10 million gallons of ultra-pure water every day.
Wow.
Company-wide, that's 150,000 tons of water daily.
And the 2021 drought nearly brought things to a halt.
It was the worst drought since 1956. The government had to divert water from 180,000 acres of farmland just to keep the fabs running.
It shows you the priority, but also the strain.
And on top of that, TSMC consumes almost 9% of Taiwan's entire electricity supply. That's projected to hit 12.5% by 2030. Those EUV machines are just electricity-consuming monsters.
So given all this risk, geopolitical, seismic, environmental, it's no wonder the world is scrambling to diversify. The U.S. has the Chi-Chi-PS Act.
Right, authorizing $280 billion to try and boost domestic production. The goal is to get to 20% of advanced chips made in the U.S. by 2030.
And the big test case for that is TSMC's own plant in Arizona. How's that going?
It shows that reshoring is expensive and it's hard. There have been delays, cultural clashes over the work culture, and complaints about a lack of specialized U.S. workers. And the bottom line,
The cost.
chips made in Arizona will cost at least 50% more than their Taiwanese equivalents.
Meanwhile, China is pushing its own massive fund to achieve self-sufficiency.
Their main foundry, SP, has made some technical progress. They managed to produce a 7-nanometer chip using older tech without EUV machines.
Which is an achievement.
It is, but that process costs 40 to 50% more than TSMC's equivalent. It confirms they are still at least 5 years, maybe more, behind the leading edge. The gap remains vast.
So if we pull all this together, what's the final verdict on the company at the center of this?
Well, NVIDIA's CEO, Jensen Huang, called TSMC one of the greatest companies in the history of humanity. And in many ways, he's right.
Its founder, Morris Chang, enabled the entire modern tech world.
But he also, inadvertently, created the world's biggest single point of failure.
So the question isn't if the world needs Taiwan anymore. It's how fast can the world diversify away from it? The next global confrontation might be one in nanometers, not on battlefields.
We've now established this central tension, a $1.5 trillion technological choke point sitting on a very vulnerable island. In the deep dives ahead, we're going to explore all the key players in this chess match. The Dutch company, ASML, that holds the keys to the kingdom.
America's massive bet on reshoring.
And China's desperate push for technological independence.
For now, we'll leave you with this thought. The world remains utterly dependent on an island that is both seismically active and politically contested. And the entire geopolitical debate boils down to one simple, maybe horrific, calculation. What happens if the cost of not having control over this technology begins to outweigh the catastrophic cost of destroying it? The answer to that question will define the stability of the 21st century.